Hi, good morning, students. So, in periodic classification of elements, we had already discussed about one of the important periodic trends, that is atomic size. Okay, how does it vary across the groups and periods? So, I had told you earlier on that atomic size increases as we move down the group, whereas it decreases as we move from left to right across the period. The reason for that was, if we move from top to bottom in a group, the electrons are being successively filled in higher energy levels because principal quantum number value increases. Whereas as we move from left to right, the atomic size decreases because electrons are being filled in the same energy level. Okay, so n value remains the same. So we know that therefore the effective nuclear charge increases as we move from left to right. So there is a serious consequence of atomic size on the other periodic properties like ionization enthalpy, electron gain enthalpy, okay, or metallic character or non-metallic character, or electronegativity, or polarizing power, or polarizability of anion, okay. So the solubility of metal carbonates, bicarbonates, or sulfates, hydroxides, etc. So the term here, the periodic property given here is ionization enthalpy. So it is the energy required or the enthalpy change taking place for the removal of an electron from the outermost shell of an isolated gaseous atom. Okay. So when an element loses an electron, it forms the positively charged ion. We call that cation. Okay. So what happens when we move from left to right or from top to bottom in a group? Okay. So ionization enthalpy actually varies with atomic size. It also depends on the electronic configuration of the atoms. Okay. So if we move from top to bottom, the ionization energy decreases because we know that size of atoms increase. So electrons move away from the nucleus. Okay. So there is a lesser force of attraction between the electrons and the protons. Further, if we move from left to right, the size decreases. Also, the effective nuclear charge increases across the period. So ionization energy increases. Okay. So we know that as the ionization energy decreases down the group, we know that metallic character increases. If we move from left to right, the ionization energy increases, so non-metallic character increases. Further, if we remove one electron from the valence shell of an isolated gaseous atom, it's called as first ionization enthalpy. If we remove second electron, it's called second ionization enthalpy. Okay. If we remove third electron, it's called as third ionization enthalpy. So you can see here, it's clearly shown that ionization enthalpy 1 decreases. It is less than the second ionization enthalpy and lesser than the third ionization enthalpy. Because as you remove electrons successively from the valence shell, the more positive charge is getting accumulated on the atom. So electron removal becomes difficult in the successive steps. Okay. But if we see as per as electronic configuration is concerned, it's always difficult to remove the paired electrons as compared to unpaired electrons. So if at all, if we move from left to right, you will see some variation in the first, second and third ionization enthalpies. So whenever you are seeing any unpaired electron being removed, there you can see some different trend being observed. Okay. So another term here is electron gain enthalpy. It is the energy liberated when an isolated gaseous atom accepts an electron. Okay, because whenever an electron is accepted, negative charge is present there. Okay, the electron pairing may occur. For example, in case of halogens, there are 7 valence electron. When you add another electron, it makes the p subshell as completely filled. So the extra electron added increase the electron repulsions. Okay, so in order to minimize the energy of the system, so it releases the excess energy in the form of heat energy. Okay, so we know that ionization and this electron gain enthalpy is taken as negative, whereas the electron ionization enthalpy is taken as positive, whereas electron gain enthalpy is taken as negative. So again, we can say that electron gain enthalpy decreases on moving from down the group, top to bottom, and the electron gain enthalpy increases as we move from left to right. Again, it depends on the size. So we'll discuss more concepts we are discussing as such. Okay.